So we're going to work towards wrapping this exercise up with just a couple of things. We want to make this game, this experiment, just a little playable. We're not going to keep score in this exercise. We're going to do that in the next project, but we want to focus on some simple mechanics. And so I've pushed forward and I've added a couple things, and I'll just kind of talk through and give a really quick demo of what I've done here. But I've just tweaked some things a little bit. So right now you can see that the sphere is bouncing. So I have two bounce materials, one on the platform and one on the sphere. And I also have the player platform tilt a little bit in one direction because there's a couple of different ways that we could add a little bit of randomness to this and a little bit of control. But I thought the best way to do this was to do a simple set rotation when the key is pressed. So you can see if I press to the left, it rotates to the right just a little bit. And same thing if we press on the D or the right key. So kind of gives me a little bit of control. We're not going to account for things like the sphere going off screen or hitting the ground, but we just want to focus on a little bit of player control. And then we'll talk about some alternative ways to handle this. So really quickly, I've created two physic materials. I created one that's called ball bounce and one that's called platform bounce, and they're virtually identical. I've just set their bounciness to 1. I've left their bounce combination to average. So on the platform bounce, I've assigned the platform bounce to the box collider of the platform and the ball bounce to the collider of the ball. And if you look at these materials, if I right click and choose to create, and I create a physic material, there it is. I have a default physic material here, and I'm just bumping the bounciness up to 1. The bounce combined, if two objects are bouncing off of each other, and they both have a bounce material, it will either average the bounce, or we can set it to a couple of other things. We can use the minimum value, so if we have one bounce set to 0.1 and we have one bounce set to 1, it would use 0.1 instead of 1. So it's a way to kind of control how the bounces are combining. We can multiply the two bounces together, or we can maximize it. So this is kind of a starting off with a continuum here. We get the difference between the bounce, we get the minimum of the two. So this is kind of the lower end of the scale, the minimum. And then we can multiply those and maximize the bounce. And again, if you ever want a clearer definition of one of these components, just click on the little question mark here, and it'll take you to the live documentation to define that. So I've assigned bouncy materials to both the platform and the ball, and that'll, instead of using the same material, that'll give me control to adjust the platform bounciness. So if I want to take that bounce down a little bit, and same thing with the ball bounce, and then again I can start to multiply those and do some different things with them if I want things even more bouncy. Okay, so we have this basic kind of keep the ball up in the air mechanic. There's still no artwork. We'll cover artwork in the next project. But we have a simple playable mechanic. Now, if I look at my player control, I've added a little bit to it. But these are just simple actions, and I'll just walk you through. And so the procedure of adding these, I'll just walk you through the logic of it really quickly. So we have the get key down and get key up on the idle state. So we're listening for a key press. The A and D are operating as left and right keys. If it gets those, it's passing it off to the left and right states, just like we covered in the previous presentation. The only difference in the idle state is that I've added a set rotation. So you can find that in the transform. And inside transform, there's a couple of different options. There's rotate, which we've looked at, but we don't want to rotate. We don't want to rotate over time. I'm doing a simple set rotation. And setting the rotation to 0, that means that every time it comes back to idle, this platform will reset its rotation to 0. And that's to account for what's happening on the right and left states. So if we take a look at the left and right states, they're just kind of complements to each other. They're doing the exact opposite of each other. So we talked about in the previous presentation, we're listening for a get key up to reset. We're translating. I did change the translation from self space to world space, and that's because I started to rotate the platform. And just to demonstrate that, if we move to the right now we're moving in world space. In other words, we're moving along the world's X. By default, translate's going to show up in self space, and because I started to rotate my platform, or I set the rotation of the platform, which we'll see here in a minute, in this case, if we rotate to the right, it's starting to climb because it's moving in its direction of its own x. Okay, so it's a way to account for that. We can set that to world space. I'm listening for for a get key up to release the D key, but in the previous demo, we noticed a little bit of a bug where we could mash both the keys and we could get stuck. And so to account for that, I just listened for a second get key down, listening for the A key. So if we press the D key and then we press the A key before we release the D key, we're just passing it over to go left. So just a little bug squash, you can experiment with that. But really the big difference here is that I included a set rotation. And during the set rotation, I'm rotating along the Z angle, so along the blue axis, and I chose to do just 5 degrees. And again, this is optional, but I just wanted to share with you what's happening, just some of the little tweaks that I made between the presentations. So I added a bounce to the platform and the sphere, kind of corrected for being able to press the A and the D key at the same time. And you can see that we can move left and right. It's still a little sticky in some places, but we'll take a look at some better ways to control this as we wrap this up. So, and then of course going left is just kind of doing the exact opposite of what right is doing. So we're setting the rotation along Z to -5. And so set rotation is simply, I'll select the player 1, and we can look at the rotation of Z. So if we pay attention up here, when I hit the left key, you can see that it gets set to -5. If I hit the right key, it goes to +5. So I can see it changing here. And when we release, it manually sets, it's resetting, set the rotation to 0. So in each of these cases as well, we're not doing this every frame. We don't need to. We only need to do it when we enter. So just a couple of tweaks. Now, there were a couple of questions that came up about how we might accommodate a Z direction as well. And so what we could do is we could continue to build on this state machine and listen for 2 additional get key down. And just to mock this up, I'll do the W key so that we can send it back in the Z direction. So we'll listen for input, and we're going to get key down. And from get key down, this time around, we'll listen for the W key. And we want a send event. And so in this case, we need a new event because we want to create a go forward state. So I'll create a new event. We'll say go forward. Now we're getting a little error again because we don't have the transition set. So I'm just going to rearrange this a little bit so we got a little bit more room to play with here. I'm going to right click on the idle state and add our new transition, our go forward state. And I'm going to wire this to another state. So I'll right click, add state. This is the going forward state. So I'm following the same convention that I created before. We'll wire go forward. Okay, and then so we'll listen for the W up key. So we're going to get key up. We're going to listen for W so that we can reset. And of course, I had a few other get key ups and downs to account for a little bug squashing, so we don't get stuck if we mash too many keys. I'm going to borrow the reset transition here. We'll add that and wire that back to idle. So right now, if I play this, it's not going to move because I don't have the translate in there, but you can see when I hit the W key, it passes to the new state. Okay, so that's a testable little loop there. So I see that the logic's set up right. So the next thing I'll do is just add the transform. And the transform, we're going to do a transform translate, just like we did on the other states. Sometimes I've noticed that when you double click add action, it just disappears for a second, but if you stick with it, it'll stick. So we want to move this along the Z axis. I don't remember the rate at which we move this, so I'm going to go check in the, I'll check our translate. We're moving at a rate of 5 units. So I'm going to go to the forward direction and I'll translate along Z because we want to send it along the Z axis. Now, the positive direction is always in the direction of the arrow, as long as we didn't rotate or move this object. So Z, the forward direction, is in line in the way that the blue arrow is pointing. So if I toggle this variable value and key in a hard value of 5, we'll leave everything else default. I should get the result that when I press the W key, we move back in space, and we do. Now, I don't have the S key mapped right now, but it would be just the same mechanic here. And there was a question that came up about copying entire state machines and states, and so I'll just demo that concept really quickly. I basically have just about everything that I want here, minus some of the other things like rotating the platform and accounting for some of the other keys, but let's assume that I've squashed all those bugs for the forward state. I could create a going backward state based on this state by right-clicking on it, copying the state. I'll right-click and paste the state over here. I'll change its name to backwards. And that saves me a lot of clicks, because now I can just translate in the opposite direction. So I'll change this value to -5. The get key up that I would be listening for, in this case, is not going to be W. I'm going to map this to the S key, so I'll swap that to the S key. I'll wire back the reset. Now I'll jump over to idle, and I'll just borrow the get key down. So I could either go through and look for the input here, or I could just borrow one of these, and I'll click on this little cog here, and I'll say copy selected action. I'll click on the cog again, and I'll say either paste after this action. I could replace or paste before, so I'll just do a paste before or after, give me the same result. And instead of listening for the A key this time around, I'll listen for S. Now I do need a new transition event. So instead of the S going left, that would be a bug. So I want to create a new event, and I'll just say go back. We'll right click and add a transition to go back, and then wire this over. And so now we have a forward backward state as well. Again, it does not, right now it does not rotate in the same way. So that is just giving me a little bit of randomness here, which I like to be able to control. If I want to kind of get the ball to go to the left or right, I can time things and just, kind of get it to move around. And so maybe there's a basket that I'm trying to get into, or some obstacles that I'm trying to hit up here. And we'll get into some more game object mechanics in our next project, but we just wanted to talk a little bit about player control, building a simple, game mechanic that relies heavily on some of the things that we did in the Gravity Lab project. So just something to experiment. Now, in the next presentation, we're going to wrap this up, and this is really like the Gravity Lab. This is just a sandbox, something to play with, experiment with these concepts. It's really about familiarizing yourselves with the workflow of Playmaker, getting in, making some mistakes, creating some bugs, and figuring out how to fix them. So experiment with this. This is really open to your interpretation, but what we want to do is we just want a simple bounce mechanic, and then implement any of the stuff that you think that you could repurpose from the Gravity Lab, or even pick up the Gravity Lab project and add some simple player control in this. So I'll just move aside here and kind of goof around with this. In the next presentation, I'll add a couple of alternatives. There'll be a little bit more advanced way to control. We'll talk about some variables. We'll cover variables again in the next project. So I'll keep the next demo optional. But for this project, simply build a simple player platform with a sphere that bounces that you can control to kind of keep it up in the air. At that point, we'll move on to our next major project, which we'll spend a significant amount of time on. Feel free, again, to really play around and experiment with this and incorporate stuff that we've done from the Gravity Lab, or even go into your Gravity Lab project, save the scene as a new level, and introduce player control into it would suffice as well, and just see what you can come up with. Make sure that you post your results, both whips, works in progress, screenshots, and or screencast to the discussion board, just to keep us all posted on what you're doing, and then post your final builds to the discussion board. I'll add some other comments about a couple of folks are having trouble building for alternative platforms, and I did send out an announcement to that, but I'll remind you that just build your native platform. if you're having problem building to the alternative platforms. In other words, if you're working in Windows, just build for Windows. If you're working for Mac, just build for Mac. But if you do that, make sure that you include a screencast, so a screen recording of your game being played by you when you post along with it. If you're not having a problem building to both platforms, Mac and PC, just continue to do that and post those in the discussion board. And I look forward to seeing your work. Stay tuned, because we will cover an optional advanced setup for player control in the next presentation, but again, it is optional. So have fun with it, and as always, look forward to seeing your work in the discussion board.